By the way, this right here, our answer is the picture. Okay, our answer is the actual picture. I don't have any numbers here, so I'm just visually I'm showing you what it is. Okay, let's do this one. What if I give you this vector? Let's call this one straight up. Let's call that V. And let's do the vector that goes, let me see if I can confuse you. From here to here. Let's call that the vector W. I want us to find V plus W. All right, so what are we going to do? Tail to tip, right? Tail to tip, tip to tail, however you want to say it. Which one do you want to move? Please, raise your hand. I don't like when everyone's yelling over each other like that, please. Which one do you want to move? The which one? Which one? You want to move the blue one? Keep the red one where it is. You okay with that? Okay, so if I do let me do it on a separate picture. That way you can really see it. We're going to leave the W one here. And then we're going to take the blue one and attach the tail of this to the tip of that, right? So what would I do to attach it? Where do I move it? Left, right, up, down, what?
Down.
Just down, right? Just down. So it would become, it would be like this, wouldn't it? Goes up. Now I can't tell because it's not a perfect drawing, but do y'all agree to be something like that? This is our V. Yes? So now imagine you have W and you're adding V to it. So you start here, you go W, then V. That's where you end, right? All right? I was like that a few weeks ago. Terrible. So what is the answer? I need to draw this vector. Where does it start? Where does it stop? Who can tell me in vector language where this vector starts and stops? What is that Christmas Vacation where the dog's under the table? You know what I'm talking about? Is it Christmas Vacation? Y'all know what I'm talking about or not? No? Yeah, the dog's eating the dry turkey and like it's like choking and then finally he's like, oh, sounds like you got it. No? Okay. All right, come on, y'all are stalling. From the what of what?
From the tail of W.
From the tail of W to the
Tip of V.
tip of V. That's exactly the way I want to say it. The result, this right here, goes from the tail of W to the tip of V, right there. That is W plus V. That vector right there. Okay? That's one way to do it. Okay? When I asked which vector do you want to leave and which one do you want to move, the suggestion was to leave the W and move the V. Let's do it the other way. All right? On this one, let's leave the V and move the W. So let's take V, let's leave V here. Okay, there's V. And then W, I'll do W dashed so you can see where it was. W was like right here, right? That's where W was. That's what W was. We're going to do that, and we're going to take the tail of W and attach it to the tip of V. So that means we're going to take this, let's move it up and over. You'll see that? Up and over. So it'd look like, I don't know, something like this. Close enough for y'all? That's W. So where's the answer? Where does it start? Where does it end? How? Say it.
From
The what of V?
the tip of
You got it.
The tip of V.
Tip of V is here.
Oh. Yeah, to the tip of V to the tail of W.
That's also the tail of W. I think you're getting the, this point right here you could say is the tip of V or the tail of W. Our vector should, see, look, we're taking V and we're adding W, right? So we start here, we go up and then back down. So what is the result? It's the same as going from here to here, right? Like going up and down is the same as just going straight like this. So from the what?
So the tail of V to
Tail of V to the tip of W. Right there. Y'all see that? That is V plus W. Are those two answers the same? My drawing's not perfect, okay? But do y'all agree those are the same vectors? Do they have the same length? Yeah, they should, right? Do they have the same direction? Yes. With me? Yes.
Could you ever do tail and
Tail
tail?
to tail?
Could you ever add the W vector to the tail of V?
Okay, so could you do this? I think what you're saying is, okay, let's start where this was our original picture, right? And you went like this. You're saying, instead of doing, in both cases that I've done, it's been tail to tip, right? Tail to tip. And then we could choose which one we do. You're asking, can you do tail to tail? Okay, so if I do tail to tail, watch, then just move this one over, I get this. Right? Move that over. That's tail to tail, right? Okay, that doesn't work because now if I ask you what's the result, like where do you start? Like we start here and then what do you do? Go up and then what do you do? You see, because you're here now, you have to connect them together. See, they both have the same starting point here. So, oh, thank you. So this doesn't make sense for us to do. Vector addition is always tip to tail or tail to tip, however you want to do it. But it's never tail to tail, it's never tip to tip. Good question. All right, so let me see. We put here, I put up on the board, when we add two vectors together, we take the tail of one vector and paste it to the tip of the other. That's the definition of vector addition. Shall we do another? One more? All right, this time I'm not going to give you, yes?
On the last one, you were saying that the answer is actually the picture.
Uh-huh.
Is that the same for this last problem we did? Like this would
Yep,
be considered
that black vector I drew is our answer.
Okay.
Mm-hmm. Okay, let's try this one. I'm going to try and confuse you by not drawing the x and y axis. Because remember, vectors can be anywhere, right? They can live anywhere. So let me draw my first vector. I'm going to make it go like this. I'm going to call that v, okay? Then I'm going to have another vector here. I'll do it in red. Let's make this one just go like this. Let's make this one kind of long like this. That's w, okay? And I'm going to give you a third vector. My third vector is going to be this vector. Small vector there, u. Call it u. V, w, and u. I've given you three vectors, yes? Let's find v plus w plus u. I want us to add all three vectors together. So here's the way I'm going to start. I'm going to start with v. I did. Why do you look so surprised? Is that my first? Let me make sure our classmate's not dead. No, she's not laying on the sidewalk over there. Okay. All right, so that's v, right? Now I'm going to add w to it. So I'm going to go tail to tip. I'm going to go the tail of this to the tip of that. So that would be, I have to make sure I've got the right direction, the right length. It would take me down, I don't know, right about there? Good enough? Close enough? That right there is W. See, I'm just taking these vectors, just sliding them around, right? Moving them around. Now I need H. I'm sorry, not H, U. U is this one, right? So I'm just slide it over here and put it right about here. Tail to tip. About right there, right? That's U. And so my answer is the vector that's connecting what to what? Tail of V to tip of U. So it's like you follow this path. If you start here, go here, then here, then here. What you really are doing, starting here and ending here. That right there is V plus W plus U. Okay? Yes?
So why would it be tip of U to tail of U?
Tip of U to tail of what?
To V.
To tail of V?
Wait, no. I don't know if I'm saying this right. Okay, why would it be that way and not the other way? Like the vector we got?
Oh, why would it not go from here to here? Good question. Is that what you're saying? Why doesn't it go from here to here?
Yeah.
Because think of it like a path, okay? Like if I asked you to first, imagine you're like an ant, okay? And I say, first go V, you go here, right? Then I say, okay, now go W, you go W, right? And I say, now go U, so you go here, right? I said, look, you wound up here, right? So give me, like, at the end of the day, what did you really do? You went from here to here, right? This is the result of all this path results in you really starting here and ending here. Yes?
So when doing these questions, it's like trying to find the empty space, like trying to connect all of them?
It doesn't always connect. Well, you know, if you have three vectors, you should.
How there is an empty space of where something needed to be to connect all four of them.
I suppose you could look at it that way if you wanted to. Yeah. We almost sent the search crew out there.
It kind of reminds me of a map. Like you give directions, tell them where to go, and you're trying to figure out as the crow flies.
Yeah, like if you were to say, you know, go to Austin. This isn't Austin. But go to Austin. Go to Houston. Go here. Then really, what you could have done is just gone from here to here, right? This is what is called the resultant vector. It's the result of everything. Now, the reason why I don't want you to get too like bogged down on this drawing, okay, and like thinking of it as a drawing is because in the real world, here's what you can imagine. Imagine we have this object, right? And then we have maybe the force of gravity pulling it down, okay? And then we have some wire that's holding it over here. And then we have some other wire that's connecting it like this. And so what you have is gravity, this pulling this way, this pulling this way. And the question is, well, what's the result of all of those things together? The result of all of those things together, what's really happening here is that, forget all these vectors, if you add these vectors together, the result is that this object's going to be moving like that. It's this being pulled, this being pulled, this being pulled. The result is that you're pulling the object in this direction. And the length is basically like the force that you're pulling with. The longer the vector, the stronger the pull. Does that kind of make sense? Like this is a very small pull in this direction. This is a very small pull in this direction. Y'all know I'm morbid, right? So we can think of it as, let's say that this is like a dead animal. Okay, and then you've got like a hyena that's attached to it over here, is pulling on it, right? I want some of that. Then you got another hyena pulling that way. This hyena is a little stronger than this one. Then you have this big hyena over here pulling this way, right? They're all pulling on this. What's happening? The whole carcass and everyone is actually going to be moving in this direction. That's the result of all three of those forces together. Yes. I mean, this is how we figure out how objects are moving through space. You look at all the forces acting on them, and then whatever, they could have all these different forces, but the result is, you know, which way the direction is pointing and going. All right, we're getting ahead of ourselves. All right, let's continue. So I've shown you so far how you add vectors visually, right? I've given you a visual representation of vector addition. How do we add vectors if I give you the vectors in the component form? So what if I give you, right, what if you're given some vector v, which is the vector v1, v2, right? Those are the two components of the vector. And then I give you another vector, let's say w, and that has two components, w1 and w2. If I want you to add those two vectors together, I've got really good news for you. It's very simple to do. If I take v and I add w, all you do is you add the components. Add the x components, add the y components, and you're done. Let me give you an example. Let's say v is the vector, let's go with that one we had before, 8, 5, right? Remember that vector we had? 8, 5? What would happen if I take that vector 8, 5, and then I take the vector w, let's make the vector w negative 2, let's go negative 2, 4. What would happen if I asked you to add them together? What would we get? So when you add two vectors, what do? You add their components, right? Just add up their components. So 8, add negative 2, what do you get? 6. And then take 5 and add 4, you get 9. That's the vector addition. Now visually, if you wanted to see this visually, I'll try and show this to you visually what we just did. We took the vector, let's say v, we'll make it blue. That was the vector that goes out to the right 8, up 5. That's right here, that point. It's this vector right here. We took that vector, that was v, and we added the vector w. W is negative 2, 4. Negative 2, here's 4, so I'm like right there. That's that vector w. Okay? What was our answer? 6, 9. Where's that? We'll go to the right 6 and go up 9, which would be, I don't know, somewhere around right there. That's the vector 6, 9. Y'all see that? Do y'all see that that vector is what we would get if we just slid this red one over and did tip to tail to tip? Right? If I take that red one, move it right here, I would get the black vector. So I'm just trying to show you that this makes sense, that when we add those two vectors, we get this result. Questions there? All right, let me continue here. How do I want to do this? If we are given v equals v1, v2, what is negative v? What do you think negative v is? I'm just asking you, this is more of a thinking question. What do you think it is? V is some vector, right? It's got some length, it's got some direction. What do you think taking the negative of that vector is? Swap the components? You mean like if it's 8, 5, do you think negative makes like switch like that? Is that what you're saying? Well, that's one sort of conjecture. So maybe we switch the components? Seems like reasonable to me, maybe.
Wouldn't the tip and the tail be flip-flop? Like if you got a vector that's going like tip, tail, would it just be?
So like this one right here, 8, 5. Let's just draw that one. 8, 5 is this vector right here, right? That's the vector 8, 5. And we're calling that the vector v. I'm trying to get you to think about what, I'm trying to get your opinion as to what you think the negative of this vector should be. So one conjecture is that we just flip these components, which would be, what would that be if I flipped it? 5, 8? And that would look like this. You go out to the right 5 and go up 8. So you'd be here instead. I'm asking as a question, do y'all think it makes sense, yes or no, that if this is v, that would be the negative of v? Probably not. I did switch the components, right? So maybe that's not what it is. What about, instead of switching the components, what if we just change the signs, right? Think of the negative in front almost like a -1 that passes through each of these and makes each component negative. So if I change this, we were kind of thinking, is it this? And then we're thinking maybe not. Then the other idea is maybe we look at the vector -8, -5. Where would that be? Well, that would be to left 8, right? To left 8, and then down 5. Wouldn't it just be that same vector, but just that way, like that? Does that make sense that that would be negative v? Do you like that idea? That is correct. That is what negative v is. So how would we say that? What is negative v? If this is v, right, the negative v would be the negative v1 comma negative v2, right? You're just changing the signs of each of those components. That's what it is algebraically. You just switch the signs. But more importantly, it's the same vector but pointed in the opposite direction. It's the same length vector but opposite direction. Was there a question? I thought I saw a hand go up.
Yeah.
Yes?
When you can solve for negative v, would you put the sign after you get the vector, or?
You would be given a vector,
Oh, okay.
and then I'd say, tell me what negative of that vector is. You would just change the signs. Let's do another example.
The vector would already be given.
Yeah, the vector would have to be given for us to figure out what the opposite of it is. So let me try this one. If, let's say that v is equal to the vector -3, 5, okay? Then what's negative v? +3, -5. That's right, that's what it is. It's just change the signs, that's all it is. But more importantly, whatever this direction, whatever this vector is, right? However long it is, whatever direction it's in, this vector has the exact same length, but points in the opposite direction, right? Okay. Now, with that in mind, I'd like for us to consider the following. If v is some vector v1, v2, and w is some other vector w1, w2, what is v take away w? So you know when we were adding vectors, it was tail to tip, tip to tail? Tail to tip, tip to tail, right? That's the way we added vectors. Here, I'm asking you to subtract vectors. So how do we do subtraction? This can be weird, okay? Which is why we just established this property right here. We just established this property so that I can explain this. Does it make sense to you that this would be the same as doing v, but adding negative w. Right? Don't we always look at subtraction as being addition of the opposite, like addition of the negative? Right? Back in the good old days when we were doing like, what's 4 take away 3? Well, that's the same as 4 adding negative 3, right? That's the same operation. I want us to think about vector subtraction that way. When I take v and subtract w, I want you to think about taking v and adding what? What is this? It's the vector that points in the opposite direction of v. Of w, right? So let me see if I can make this clear with an example. By the way, this is vector subtraction, which is right there in the notes. I can send you all that file later if you're interested in having those notes. Okay, so let me go back to a picture. Let's do this. Let's let this be u. Okay? Let's let this let's let that be w. All right? I want us to find u take away w. Well, to do that, the first thing I'm going to do is I'm going to rewrite that as u take away negative w, right? Oh, sorry, I forgot to add. Sorry, add negative w is what I meant to say. So u take away w is the same as u plus negative w. So let's do this. Where's negative w on here? Negative w is the vector that has the same length as w but points opposite direction. So if I just take this vector and point it up like that, that's negative w. Do you all agree with that? And so what I want to do is add that vector and that vector together. So I'm going to take this one, and I'm going to attach the tip of this to the tail of that. Tip of this to tail of that. So let me draw that over here. I'm going to just move the vectors around. So here's the vector u, right? And then I'm going to take the vector negative w, which just goes straight up like that. That's negative w, right? And do you all see it? U plus that vector, the resultant is going from here to here, right? From here to here. So this vector from here to here, I missed it. There, I'll make it real big. There. That is the vector u take away w. Does that make sense how I did that? Any questions?
So you add both the positive and the negative? Or
I didn't even use the positive w. I didn't even use it. What I did was I found negative w, so I found the vector that had the same length but pointed in the opposite direction, and I used that vector and added it here. Tip to tail right there. That's this. And then I connected the two. All right, new question. What's w minus v? Yes.
Question.
Yes.
Does it matter as far as when we draw the connecting piece equivalent to the pencil line we made? Does it matter where we start our tail and tip from?
Like this and this?
Yeah, does it matter?
Like, could you draw it over here?
No, in one where it's like drawing it as an answer, it's not particular to where we would need to have like let's say we started off at U and went up to W. Would we need to start our point from there and point upwards with the purple line? Or like, does it matter if it's the same either way? Well, I think it's not the same directions. It's not the same.
I'm not. Are you saying go from here to here instead?
Yeah, like is that something that would not be correct?
That would not be correct because we're trying to take u and we're going to add negative w. So we start at the tail of u, we go to the tip of u, then we go tail of negative w to tip of negative w. So the result is that we started here and ended here. So it goes from here to here.
Okay, I see.
Got it? Now look at this one. What have I done? What's the difference here? Switch the order, right? Does that change our answer? What do you think? Yes, it's going to change our answer. Let's see that it does. So this, I'm going to go w but I'm adding what? Negative v. You see, I'm changing the minus to adding the negative.
What's the V?
Yeah, I don't have v, sorry. It's u, right? I used u, I'm sorry. I've been using u and v. You're like, what the hell, man? All right, this is u, sorry. U, move that to u. All right, yes, yes? All right, so let me look at this. Where's negative w? Negative u. Isn't it this vector right here? Same length, opposite direction. So from here, like that, negative u. There's my negative u. So let's add these up. I'm going to start with w, right? Start with w. W's right here, goes down. Let's start there. W goes down like that. And I'm going to add to that negative u, which is this black vector right here. And I'm going to go and take the tail of this one and attach it to the tip of this one. So here's negative u, roughly. All right. So the result is what I would get if I started here and ended here. Right, like that. That is w, take away u. Are these two the same? No. They are opposites though, right? They appear to have the same length, but they're pointed in opposite directions. Okay. You all doing all right? Yeah? We continue. Scalar multiplication. One thing we have not done yet is we have not, so let me kind of recap real quick. Right now, we have a general idea of what a vector is, right? We have a general idea of what it means to add vectors together, tip to tail, tail to tip, right? We have the idea of what it means to take the negative of a vector. It means you just basically do the opposite direction, right? And now we know what it means to subtract two vectors. It turns into really adding the opposite, right? Adding the opposite. Now what we want to do is we want to multiply, right? This is almost like we're back in grade school, right? When you were learning numbers, right? Numbers, the first thing they taught you is how to add and subtract, right? And then after you learn how to add and subtract numbers, they taught you how to multiply and divide, right? So we are now going to talk about multiplication. And this is where things get weird. Because when it comes to multiplication with vectors, there's three kinds of multiplication. Three kinds. When you're talking about numbers, right? If I tell you to multiply two numbers, there's only one type of multiplication, right? If I say, hey, what's 3 times 4? You don't go, what type of multiplication are you talking about, right? That's not what you say to me. When you multiply vectors, there's 3 different types.